All right, welcome back to another lesson for Algebra 1, lesson 105. So after today, we will have 15 lessons left. This is also the first video I'm going to do after we found out that there's not going to be school until April the 20-something. Not that there's no school, okay? I misspoke there. All right, we will keep on having school, but we won't meet at the school building until the 27th, if God wills it. Okay, that's the truth here. We don't know what's going to happen, so hope you're staying safe, that you're staying busy. And I know most of you are going to be like, oh my goodness, we have so much work, but I'm telling you, there's so many people that are at home and they don't have a lot to do, and they've played a lot of games and they've done all these things, and they start to get kind of tired because they start to get repetitive. And so, this actually is helping you keep a little bit more of a normal rhythm to life because you're doing work. And it's really important for us not to just be lazing around and be like couch potatoes or just playing games and things like that. It's important for us to stay active. So if you can, do push-ups, do sit-ups, do pull-ups if you can. If you have a backyard, you should probably go back and kick the ball, because I know most of you have a soccer ball. Or run around or do something active. It's really important so that you don't stay, you don't start getting too comfortable. Let's just call it that. All right. But today we're going to do lesson 105, right? So today is recognizing extended geometric sequences. It's not a super hard lesson, but it's something that you need to know how to do. And hopefully by now you understand the difference between a geometric and a arithmetic sequence. The arithmetic sequence is when we add or subtract by a common difference. The geometric sequence is when we multiply or divide, but as you know, there's no such thing as division. It's all multiplication. Multiplication of the reciprocal would be the division. Doesn't matter what it is. So for a geometric sequence, we are multiplying by a number or its reciprocal, and so that's how we get that difference. And that is what we're going to be talking about, how to recognize it, how to extend it. Okay, so let's actually get into the lesson. All right, so in the first example, we have three different parts to the example, and all of them is find the common ratio. Okay, so because it's not an arithmetic sequence but a geometric one, we're not going to call it a common difference. We're going to call it a common ratio. And so let's just do it. Okay, so what we are supposed to do is go always backwards from 12 divided by 4, 36 divided by 12, 108 divided by 36. And so if you divide 12 divided by 4, you're going to get 3. If you divide 36 divided by 12, you're going to get 3. If you're going to divide 108, divide into 36, you're going to get 3. How do I know that? 3 times 6 is 18, and 8 goes down, and a 1 goes up. 3 times 3 is 9, plus 1 is 10, 8, or 108. And so the common ratio for this one, because we literally divided the second term by the first term, the third term by the second term, the fourth term by the third term, we got a common ratio of 3. And so that's the common ratio. Obviously, you have to write the common ratio is 3. All right. And here, we're going to do exactly the same thing. And go backwards like that. Because what happens is that we're always going to find the what we are multiplying by, okay? Not what we're dividing by, but what we're multiplying by, and that is going to be the ratio. So when I divide 80 by 320, and by the way, it's negative 80, not just 80. So negative 80 by 320, what's going to happen is that the zeros are going to cancel out, and the 8 and 32 cancel out, and this is going to become negative 1/4. Okay, what about 20 divided by negative 80? 20 divided by negative 80, the zeros cancel out, the 2 and the 8 cancel out. It's going to be negative 1/4, because positive and negative is negative. And finally, what happens when we have negative 5 divided by 20? Well, it's going to be negative, and we divide both 5 and 20 by 5, and it's going to be 1/4. So all the time, negative 1/4, negative 1/4, negative 1/4. So the common ratio for the second example is negative 1/4. I told you, it wasn't super hard, but it's something that you have to know. Again, for the last one, we're going to do the same thing. And hopefully you understand that you are able to use a calculator. Let me get mine. Because obviously by now, I expect you to all have a calculator and be able to use it. So, if we're going to use the calculator, it would be 1 divided by 0.4, which is 2.5. So 1 divided by 0.4 is 2.5. Then 2.5 divided by 1, well, that's pretty easy because it still would be 2.5. And then 6.25 divided by 2.5, it's going to be 2.5. Why? Because 25 times 25 is 625, and because it has 2 decimal points, it'd be 6.25. So the common ratio here is negative 1/4, but in the third example, no, the third part of the first example, it would be 2.5. And that's it. That's the first example. It's actually really easy. I know that they're trying to trick you with hard, quote-unquote, numbers, but it's not that hard. So let's actually move on to example 2. I'm just going to show you really quickly the last example a little bit because I saw the glare that happened just as I was adjusting the camera. So yeah, that's the last example, and it is 2.5, not 25, 2.5. Let me just make that point. There we go. All right, let's move on to example 2. Example 2 has 2 parts again, and so it says find the next 4 terms. So we have the first 4 terms here, and we have to find the common ratio. If we divide 8 divided by 2, it's going to be 4. 32 divided by 8 is 4. 128 divided by 32 is going to be 4. So the common ratio is 4. So what we're doing is multiplying times 4. Okay, so 128 times 4. I know I can do it on a calculator, but I mean, don't be lazy. 8 times 4 equals 32, and a 3 goes up. 2 times 4 is 8, plus 3 is 11, and a 1 goes up. 1 times 4 is 512. Yay, 512. So we have 128, then we have next would be 512. Okay, we still have to do a couple more. So let's multiply this by 4 first here. I do have enough space here, but then I have to move to the right. And so 2 times 4 is 8. 4 times 1 is 4. 5 times is 2,048. 2,048. Not to confuse the comma of the 2,000 with the comma of the separation of the terms, like in there. So we have 2,048. Now we're going to multiply by 4. 8 times 4 is 32, and a 3 goes up. 4 times 4 is 16, plus 3 is 19. Why did I put the 1? Because 4 times 0 is 0, plus 1 is not 1. And 4 times 2 is 8, so we have 8,192. And then I'm going to multiply that by 4 again. 4 times 2 is 8. 4 times 9 is 36, so 6 and a 3 goes up. 1 times 4 is 4, plus 3 is 7. And 4 times 6 is 32,768. Let me just check that I'm correct in the book. I got 2,048. Well, I got 512, easy. 2,048, easy. 8,192, yes. And 32,768. Well, that's how you do the first part of example 2. And in example 2b, what we're going to do, or not to be, that is the question, whether it is Nobla, but that's Hamlet, and you guys haven't seen it. negative 50 divided by 250 is going to be negative 1/5. Negative 1/5. It is correct. So, how do I know it's negative 1/5? Because 50 over 250, if you cancel out the zeros, it's going to be 5 over 25. 5 over 25 is 1/5, but this is negative, so it's negative 1/5, because negative and negative is going to be positive and so forth. So then we have to do negative 2 times negative times negative 1/5. It's going to be positive 2/5, which is 0.4. But I'm going to leave it at 2/5. Because then when we multiply, it's going to be negative 1/5. It's going to be negative 2/25. Then I'm going to multiply again by negative 1/5, which is going to be positive 2 over 125. And finally, I'm going to multiply by negative 1/5, and I'm going to get negative 2 over 5 and 5 is, oh, it's 625 actually. I already know. Let me check. Yep, I'm correct. So the numbers are 2/5, negative 2/25, negative 2/25, 2 over 125, and 2 over negative 625. And those are the 4 terms. So as you see, it's not very hard, and you guys have a calculator, so I mean, this is not a tough lesson per se. And so that would be example number 2. Let's move on to example number 3, which is the last example for this lesson. Hooray, math! And I'm just checking that you can see the numbers. It's a little bit tough to see certain numbers. Again, the glare sometimes is just like, ugh. Let me see here. I think right there you can see them a little bit better. But that's it for that. All right. Now, the last example we're going to go over today, but before we go over the example, I'm going to show you this formula, all right? This formula is also written in your book, and it says A of n equals A times R to the n minus 1. Okay, wait a second. What does this all mean? R means ratio, which we already talked about. The ratio is what you have to find for each one. So in the first example, that tells the ratio is negative 3. First example of example 3. So the first part of example 3 says that the ratio is negative 3. And for the second one, we have to find it out. It's pretty easy. It's 1/3. I already know. Without looking at the book, I can tell. All right, so R is the ratio. N means the term, the number term. So the first term is 7 in the first part of in part A of example 3. And for in part B, A1, or my first term, is 1/3. Okay? So what does that all mean? It means that we need to know what it is. Like A is something, right? So A1, I'm going to put A1 here, but it's the same thing as A. So A1 means the first term. So we always need to have the first term. We need to have the ratio, and n minus 1 means the number term that we want to find. So in here we have to find the 6th one, and here we have to find the 7th one. So how do we use this? Well, A of n is just value of the term. The value of the 7th or the 6th term, so the value of the 6th term is going to be the same thing as the value of the first term. Let me just write this here. I'm going to write 7 here, but we know that this is A1, right? So this comes from here, and this is this part right there, right? So that's 7. The ratio that tells us is negative 3. Okay, so it's negative 3. And then what we have is n to the minus 1. So n is going to be 6 because it also says it here, 6 minus 1, which is 5. So my formula then is going to become 7 times negative 3 to the 5th power. So it's going to be 3 to the negative 3 to the 5th power, and that's why you need your calculator. 3 to the 5th power is going to give us a number, and then we multiply that by 7, and it gives us a very small number. And so what we're going to do is we're going to put it into a fraction. And my fraction says it's going to be 7 over 243. Oh, never mind. I made a mistake in my calculator. Okay, that's why it's important to check. I didn't put negative 3 to the 5th. I put 3 to the negative 5th, which would make it weird. Oh, okay. Now we have negative 243. Now we're going to multiply that by 7, and we get, yes, correct. We get negative 1,701, which is what we need to do. And this is one of the reasons we allow you to use your calculator. Because you see, it doesn't matter if you have your calculator or not. If you put the wrong thing in your calculator, you're going to get the wrong answer. And that's why the answer is negative 1,701, because instead of putting the negative 3 and the 5 in my calculator, I put 3 to the negative 5. And that obviously gave me a very small answer. So in here, let's do it in the second example. In the second example, it says that I need the 7th term. So a of 7 is going to be 1/3, because it's 1/3, but the ratio is also 1/3 to the 7 minus 1, which is 6, right? So a of 7, 1/3 times 1/3 to the 6th power. That's going to be 27 squared, I believe. No, it's not 27 squared. Disregard it. I was just thinking out loud, okay? So, what we're going to do is, again, we're going to put 1/3 to the 6th power times 1/3. All right? And let's try to make that into a fraction. So, this one does make more sense. It's going to be 1 over 2,187. You see? And that is how you do it. So that's one of the reasons that you also need your calculator. And this is why it makes it a lot easier. So let's move on to the last two parts of example 3. And that would be it for lesson 105. All right. Let's do this last part. So this part says 17, 8.5, 4 1/4, 2 1/8. Okay. So again, if we actually do the common difference, I'm telling you, I don't even look at the book, but I already know, because 1/2 of 17 is 8.5. 1/2 of 8.5 is 4.25. 1/2 of 4.25 is going to be 2.125. And so I know that 0.5 is 1/2, 0.25 is 1/4, 0.125 is 1/8. And so in here, what we're doing is we're dividing by, or multiplying by, we're multiplying by 1/2. So that's what we need to do. Now, the term that we're supposed to look for is the 9th term, okay? So what is A9? Okay, so A9 is going to be 17, because that's our first term, times 1/2. 9 minus 1 is 8. I'm not going to be doing the whole thing all the time. And so what I have to do is multiply 1/2 times 8. Don't worry, that's just my calculator falling. First fall. Got dirty. Whoops. Okay, now it's good. So we have 1/2
half to the 8th power. Gives us a small number. And then we multiply that by 17. And it gives us another number. And then we're going to find the fraction of that. And it's going to be 17 over 256. That's what I got. And that's what your book got. So I got it right. So I'm telling you, the formula is pretty easy. It's pretty self-explanatory. And here what we're doing is we're multiplying by 6. How come? 12 times 6 is 72. 72 times 6 is 432. And so each time we're just multiplying by 6. So the ratio is 6. I know this just by looking at it. I don't look at the book, I promise. And it says then the 5th term, all right? The 5th term, a of 5. It's going to be 1.2 times 6 to the 4th power. 6 to the 4th power is 36 squared. Which I don't know what it is, actually. It's not like I know everything. So I know what 25 squared is. 625. I know what 35 squared is. It's going to be 1,225. But I don't know what 36 squared is. So 6 to the 4th power times 1.2 would be equal to 1,555.2. And that's what I got for the last answer. And that's what your book got for the last answer. So that's it. This is lesson 105. 15 lessons more to go. We are in the end game now. No, we're actually just, getting ready to be done with the math. But, I'll let you know through Google Classroom what might happen. I'm just going to keep recording the lessons. And the test, I don't know what to do because I know some of you are in honors and some of you are not. And so what happens is that if I write the test, they would come out honors. They would come out without the help. And I know that the help sometimes does help some of you. So I'm not sure what's going to happen. But we'll get to that at some point, but not this week, okay? This is not going to happen this week. So just understand that we're going to do until lesson 108, I think it is, for April the 3rd, which is a Friday. So for April the 3rd, we're going to do until lesson 108, which is pretty good. I mean, we would have 12 lessons to go, and we would have more than like about 2 months left of actual calendar year school, because our school ends somewhere first week of June, and so we're in great shape. That's why I'm not really worried about all this. All right, so yeah, let's end it here. Like, comment, subscribe. 41 subscribers, I'm climbing those YouTube charts now, and so yeah, Raid Shadow Legends. Any minute now, it's gonna contact me. See you tomorrow.